Start. Wait for a moment. 龙安。OK， 好。Hello， 大家好。首先谢谢现场跟线上的大家参与今天科技艺术典藏基础计划关于网络艺术的保存与维护最后一场的讲座。然后我是计划的成员子权，计划主持人禹先，因为今天他工作的关系没有办法共同连线，可是他会跟我们一起在线上参与。那我们从第一场针对网络艺术保存各面向的概论开始讨论，到第二场由修复师的角度，然后来看说在美术馆内这类型的作品又是怎么样处理跟保存，然后再来说在修复师他本身扮演什么样的角色，最后则是今天要更深入的来讨论说实际修复网络艺术作品的案例。那今天讲座是由上周古根汉美术馆的修复师 Jonathan 跟来自纽约大学 Computer Science 的 Emma， 他们要分享古根汉跟纽约大学一同合作修复台湾艺术家郑淑丽1998年创作的网络艺术作品 Brandon。然后他们会先从作品的技术结构分析开始，接着在修复的过程中又碰到哪些挑战，然后如何面对这些挑战。那关于 Q&A 的部分，现场跟线上的观众可以直接使用 Slido 这个网站，然后活动代码是7036。在讲座的过程，大家都可以直接丢问题到上面去，然后如果可以的话，就请大家尽量都用英文直接留言，这样讲者也可以直接看到问题做回应。那如果没有办法真的没有办法用英文留言的话，我们也可以帮忙翻译。那现在就让我们欢迎两位讲者。Welcome to Emma and Jonathan.
Thank you. Building on the presentation that I did last week about my background as the Guggenheim's Fellow in the Conservation of Computer-Based Art, this week we're going to do a detailed look at one of the artwork treatments that was completed during my fellowship. I also have Emma here who worked with us on the restoration. And so Emma's going to introduce you to Julie Cheang's Brandon, which we restored in 2017. And let me just share my screen here so you guys can see these slides. So in order for you to be able to see the video, we're just gonna do this view of the slides. So Emma, you can go ahead.
Sure. So as you can see on the screen, Brandon was originally conceived as a multi-year narrative project in installments, which is a unique thing for this piece of art. Over 50 people were involved in the creation of Brandon, either artistically contributing certain visual elements, from a research capacity, or as writers from 1998 to 1999. And there were a series of live events that took place over that year period. And similarly, our restoration was a collaboration that took place in many stages. Dina research project by Jillian Zong and myself into a potential fix for Brandon and the current state of it before the restoration actually began. And once we did start the restoration, it was basically Jonathan, myself, Joanna Phillips from the Guggenheim, and Dina Engel, again, working as a group to lay out a plan, develop best practices for documentation, and move forward. And we, even at that stage, we had interviews with the artist, people who had worked on the piece previously consulting, in order to make sure that we were staying true to the piece as much as possible.
So second slide.
So Brandon is composed of 5 interfaces. And interfaces is a term that the piece itself uses and that we use to describe the distinct sections of Brandon. So each interface has unique themes, subject matters, and visual elements. So I'm going to just go through briefly all of the 5 interfaces, how a user will encounter them, and some things that make them unique. So the first interface is Big Doll. It's represented in the top right of the slide that Jonathan is sharing. It's the first interface that viewers encounter after visiting the title splash screen that you saw on the previous slide. It's initially a completely blank white screen, and pictures appear as users mouse over and begin to click areas of the screen. And it's meant to be a little bit of a puzzle because the pictures will disappear, reappear depending on what order you mouse over them, and only one of them actually has the ability to take you to the next page. So it's really confusing for the viewer, it's disorienting, and it's meant to kind of force you to click around and try a lot of things before anything happens. Clicking on one of the pictures in Big Doll will take you to the next interface, which is Road Trip. And Road Trip is seen in the top left corner of the slide. Road Trip is the second interface. It's the gateway to all of the others. So you can access all 3 of the next interfaces I'm going to talk about from Road Trip, but you can't go backwards to Big Doll. And Road Trip is characterized by its use of pop-ups. You can see in the slide that we're showing of Road Trip, you can see a theory pill in the top left-hand corner, and these mini adventures on the right side of the slide, where Brandon encounters various historical queer characters and has different types of interactions with them. So from Road Trip, you can go to the next 3 interfaces, Panopticon, MooPlay, or Theatrum Anatomicum. So I'm just going to go through and talk about those next. Bottom on this slide, and it has the distinctive red and blue elements. So it's modeled after Foucault's idea of the prison panopticon, and you can see the circle there in the center is where you can click on any of those numbers and encounter 12 patients, and the patients are in both medicalized settings and carceral settings. The medicalized patients are characterized by red color schemes and are often real figures, and the same for the carceral patients. They're usually real life figures. The screen on the tower on the far right of the middle picture is actually Alan Turing, and if you were to look closer at that text, it would be a little bit more information about his life and such, and those are represented by blue. And from the Panopticon, you can also go to the next interface I'm going to talk about, which is MooPlay. MooPlay is a fake chat. It's modeled after MUDs from the late 90s, the multi-user dungeons. And multiple writers wrote full short stories with fully developed characters for this section that were then chopped up and reused as these pseudo-chat characters that we'll talk a little bit more about later on. And the last one is the Theatrum Anatomicum. It's a really complicated section of the piece. In some ways, it was the most difficult part to restore. It was comprised of a virtual court, and it was the subject of 3 live events. So in '98, the Guggenheim Soho had a simulcast with the De Waag in Amsterdam, where some of these things were discussed. And then there were 2 follow-ups, a '98 forum called Digigender Social Body, where some people actually gave talks. And after that, one more in '99 called Would the Jurors Please Stand Up, where they actually had netizens fill out jury selection forms and weigh in on some of the cases that are featured in this section. So overall, Brandon's structure posed a really unique technical challenge. It has 11 Java applets. It has a lot of pop-ups, which browsers automatically disable now. And a lot of, as I said before, a lot of people had worked on it, which made it kind of a homemade piece. It's similar to if a lot of people have worked on writing a paper. It can be harder to distinguish a unique voice, to identify themes. So because so many people had contributed code to this, it was really inconsistent thematically and stylistically, which made the restoration a little bit more difficult in a lot of ways. And it made use of a lot of languages. It used Java originally for a lot of the visual elements. It was written in HTML3, which by the time we had begun the restoration is JavaScript, PHP, Perl, and other CGI scripts. So there were a lot of languages, a lot of people working on it, and it was huge. It was sprawling in terms of its structure, which offered a couple unique challenges.
Emma, can you talk briefly about why it's called Brandon?
Sure. So the name Brandon comes from a real person. His name was Brandon Tina, who was murdered in a hate crime in Nebraska because he reported a rape and was trans. And so Shuli took this real life. It's one of the most famous hate crimes against queer people in America. And Shuli took this crime and wanted to take Brandon as a character and put him into cyberspace and put him into this new environment, which is why on the road trip in particular, you see, you read text about Brandon as a character and you see Brandon as a character interacting with all of these other famous queer historical figures. If you look in the representation we've done of Road Trip, the figure in the bottom right-hand corner with the angel wings is Brandon in this kind of alien abduction adventure section of the road trip. So it's a really interesting way to take this real-life figure and kind of reimagine him as a character.
Thanks. So this web artwork was commissioned in 1998 by the Guggenheim. And as Emma said, it was quite sprawling and uses a lot of different web technologies. So you can only imagine when it began to be studied in around 2015 that there were many elements of it that were no longer functioning in contemporary web browsers. So Emma and Jillian, before I started as the fellow, Emma and Jillian had studied the work and looked at some of the non-functional parts of it. So later we decided to record a video, and I'm going to show you an excerpt of that video where I narrate some of the features of the site that aren't working. So let me just switch slides here and the video should play. There we go. The next issue is in the Garland episode of the road trip. So if I click on this image right here, you see some text on the right side under a hypnotic spell. So this text originally used the HTML blink tag. So it was a tag that you put around text to make it blink. So kind of on and off like a light. And that tag is deprecated. So contemporary browsers basically just ignore this tag and just render the text as static and not blinking. So if I click on the detour link here, this should take me to the MooPlay interface. So you're just seeing a blank page here because there's a CGI script that was written in Perl that was supposed to randomly generate text on this page. Unfortunately, the CGI script is no longer functioning, and I'll click the top of the syringe to open the surgery applet. So again, this is another Java applet, and this would have been displaying some random pictures of surgery. So you can see quite a bit of it was not working before we decided to intervene and restore the piece.
Yeah, so Brandon had 11 unique Java applets, and Java applets were basically, just to give like a really quick background explanation, they were basically just a really common way for people to do complex visuals on the web. It was really common in the late 90s. It was fully supported by all of the browsers. So it's what a lot of people used. Unfortunately, we were in a bit of a race against time with this restoration in Java applets. When we started, Chrome had already completely deprecated display Java app about halfway through with, I believe it was the 2017 version 52. Firefox deprecated its representation of Java applets. And today, Safari also has stopped displaying Java applets. So it's a dying technology, and it posed a problem, particularly for this restoration, because it was how they had done most of their visualizations. And as Jonathan mentioned, there were also deprecated HTML tags. The piece was written in 1998 and 1999, so of course, since then, the web had changed, and we'd moved entirely onto a new HTML standard. So some tags like blank were fully deprecated across all browsers. Sometimes there were things like font, the tag font, or font-related stylings in the tags that meant that things were rendered inconsistently across browsers. Some browsers had fully deprecated the font tag, or were refusing to accept certain inline style declarations. And another thing that really posed a problem was, this is a great example on the screen. The top picture is actually composed of essentially a table. It's divided into the top row, and even within that top row, there's a left, a center, and a right. And this was how a lot of Brandon was done. It was a really common thing at the time to think of web pages like tables and kind of divide them up into frames. But the frame tag itself was being deprecated as we were working on it. So we also had to translate a lot of the frames into the new version of iframes, which behaved slightly differently. And aside from those kind of technical challenges, there were also just broken links and references that had changed. So one of the live events had the Center for Arts and Civic Dialogue associated with it. That website no longer existed, so it took you to a blank page. Court documents were being improperly linked to. There were presentations that weren't rendering. Things that happen really commonly in migrations of just, well, we've moved this, so now it thinks that, you know, something is where it isn't. Those also had to be addressed in the restoration.
So during this project, this restoration project, we were also researching the commission, acquisition, and intake of Brandon by the Guggenheim. We had multiple versions of Brandon that we were looking at because there had been changes over the years to the code, but there was very little documentation on previous versions, and we wanted to build up a thick history of what had happened to the piece since 1998. So this reconstruction research also guided our restoration. And basically the goal was to understand the changes to the site over the years, who made those changes, why they made those changes. We wanted to understand the technologies that were used at the different live events that Emma mentioned, like the lecture between Guggenheim Soho and DeWog, and what data was exchanged between participants during these events. We also wanted to understand how the specific pages, web pages for those events functioned at the events, because we weren't entirely clear on that. So some of the methodologies that we used were archival research. So I dug into the Guggenheim's archives, the papers of different curators, and lucky for us, they had printed out some of their emails and other correspondence, and that was helpful for us. We also looked at invoices and flyers and press releases and other documents, anything that could give us a clue as to what was happening at different events related to Brandon, and as well as images of the events. So we had several interviews with former Guggenheim curators, former Guggenheim staff, and people who worked on the technical setup of different events. And then finally, we were looking at the code itself. And as Emma can probably tell you, Brandon, the the file set that composes the website actually has a fairly extensive archive of itself. So we were looking in there for different clues. We were also comparing different versions of files and even looking at the file structure and the file metadata, like the moved, added, and modified times on files, so that we could understand which version was what. So we also had to decide on a treatment approach or a treatment methodology for how we would go through with this code migration. You can see in the slide Emma and I discussing some of the finer points of the code. Since this was a conservation treatment, we wanted to apply conservation ethics to this restoration. And this was something very new to the Guggenheim. So the team was meeting regularly, myself, Joanna Phillips, Dina Engel, and Emma, to discuss how we would address some of the issues that came up as Emma was working on the code. So in order to apply conservation ethics, we wanted to keep the principles of reversibility, documentation of the treatment, and clearly delineating the original from additions. So reversibility is the principle that any treatment to an art object could be reversed later with minimal impact to that object. And documentation of treatments is important because we want to be explicit about any intervention we made to an artwork. We want to be completely transparent about it. And then, of course, clearly delineating the original piece from any additions or modifications that we made, again, is part of that being transparent in everything that we did to intervene. So in order to apply these ethical principles, we decided that we wanted to keep all the original code, files, and file names intact as we worked on the restoration. So file names are particularly important because the URLs actually reference the file names. So you know, the URLs for certain pages in Brandon are just paths to those files. And if we change the file names, we would break those URLs, those original URLs. We also kept additions to the code as minimal as possible. And when a new file had to be added, we would notate it with a 2016, 2017 at the end of its file name, so it could be easily distinguished as a new addition. Also, we were always testing any new code against the original piece, at least what we could see of the original piece. And that was important because as we were restoring it, we didn't want to introduce any kind of anything new visually. We wanted to keep the look and feel as close to the original as possible. Now, we also wanted to document all decisions and treatment interventions, but given that the catalog of damages was so long and that the fact that the site is thousands of lines of code, there was no way we could use traditional treatment reporting techniques to record every intervention to the code. So we had to implement alternative strategies.
Yeah, so what we did to make sure that we were taking note of every intervention that we made was basically to add that documentation of code basically as a text document. When somebody wants to edit something as a coder, they open it up in a text editor, make the necessary changes, and save it. So we took that process and modified it slightly to better fit a conservation setting by adding comments in a header that we created, which basically showed who had made a change, when, why, and allowed people to kind of immediately see what might have been done to the code. But we also put in original tag, which was basically commenting out original code that was no longer needed, with original code really big, so that it would be easy to find if somebody ever wanted to know what was the previous version of this piece, what did it look like. And similarly, new code start and new code end tags were basically to delineate when we had to add additional code for whatever purpose and when it ended. So anybody glancing, even a non-technical person glancing at the code in a text editor, would be able to see this file was edited around this time for this period. Here's where the original code is, and here's where there have been code additions. I believe we have an example
file. Yeah.
Yeah. So this is a file from the restored version of Brandon, one of the Java applets. So if you scroll up to the top, Jonathan, you can see there's the documentation header that I've just talked about. So this is the primary. Yeah. This is like primarily where we would note interventions. And from a conservation perspective, it's great because it can, if this is present, then you know immediately the file has been edited. It was on 12/20/16 for the Java applet migration of Brandon. This page is called by cell 10. The Java applet's being replaced with such and such an element. And you can see the exact revision history. So in the winter of 2016, we migrated the Java applets, and then I went back in 2017 to change some of the HTML elements to HTML5. And you can see also in the CSS, we've added CSS. So anything in the style tag is within new code start, and then new code end at the bottom of the CSS. And there is also code that's commented out with the original tag. So it you don't have to be a technical person to open up an HTML file. Yeah, there's the original code that calls the Java applet commented out. So they're really great. Basically just tells the browser to ignore it. It's still there whenever you open it up. And in fact, if you were to inspect element on any of Brandon's pages today, you would see something that looked a lot like this. You would see all of the original code clearly marked and identified, but being ignored by the browser. So it allows somebody to just open this up as a text file and read the history of the piece kind of natively, which is kind of an innovative and interesting solution to a lot of the unique NetArt documentation challenges.
So should we go back to the slides?
Yeah, I think that's what I had to say about Bluehead.
Okay.
The next one's the Git.
Yeah. So Emma spoke about the the documentation steps we took within the code. I'm going to talk a little bit about some of the documentation procedures we did outside of the code. So this was again meant to complement the code annotation. So we did end up writing a traditional treatment report for the piece. Of course, we couldn't catalog every single change to every single line, but this treatment report is more of a summary of what was done for any conservator who would like to go back and look and see what our interventions were. Excuse me. So even though it's not cataloging every line of code that we changed, since Brandon is such a large and sprawling site, the treatment report is well over 100 pages and catalogs every page that we changed and why we changed it, or kind of what intervention we did. So we also did screenshot comparisons and narrated screen recordings of the site. So we have screenshots before and after restoration, we also have video screen recordings of myself and Emma navigating the site before and after the restoration. So as I mentioned, we couldn't necessarily catalog every single change to a line of code manually, but we could use existing software called version control software to catalog any changes to a line of code. And so the version control software we decided on is called Git, and this is a version control software that's very popular among developers. So just to give you a little background on version control, it's generally designed for large teams of programmers working together and establishes a history of all changes to the code. So probably the most relevant comparison for most people would be if you've ever had a Google Doc and you've opened up that menu that says show all versions, and then you can see highlighted in different colors the different edits that people have made to a Google Doc. So you can think of version control. Actually, that's a type of version control. So in this case, you can just think of that, that Google Docs versioning, except for code in this case. So all changes that are made by someone are stamped with the time, author, and description of those changes. The group of changes is called a commit. So the person who's working on the code decides when they want to post a commit, and then that commit catalogs all of their changes and the time that they did it. Git and other version control systems also allow reverting of changes. So reverting changes means going back to previous versions and undoing the changes. So that actually allows for complete reversibility. We think that version control is a promising tool for conservation treatment in the future and could also be a good way to acquire software-based art. So for example, instead of just getting the source code for an artwork from the artist, you would get the source code under version control so that you know for sure how that code has evolved over time in different versions, and you would also know if in the future the artist makes any further changes because you've created a version controlled repository that's going to track that. So, excuse me one second. I'm going to bring up our GitHub repository for Brandon and show you an example of what version control can do. So, whoops. Let's see. There we go. Okay. So let me look at this page here. Okay. So this is the page for our repository for Brandon, and I'm just showing you the history of one file. So if you're looking at a file, it's going to show you, well, one, that Emma committed. The last commit that she did was on the 28th of June, 2017. It has a unique identifier for this commit, and it shows you how many files were changed and the types of changes that occurred. And here we're just looking at the change to one file. So you can see left and right, you basically have a before and after. So the red here is indicating that in this commit, the red lines were deleted or modified, and the green text was added. So you have two changes here. And basically what this is showing is that we had Emma's email here that we were using for testing on this page was changed back to the artist's original email here. So that's kind of a basic overview of what you can see if you're using version control for a piece. I'm going to go back, or actually at this point, I'll just leave this up for a second, and we're going to pause briefly for Q&A. If you have any questions, because I know we've thrown a lot of technical information at you, and we just want to make sure that everyone's on the same page. And I'm just going to temporarily stop sharing my screen while we do some Q&A.
Okay, I just do like not the technical question, but according to browser still updating, and after this restoration, how long would you think the website could be alive?
Oh, that's a good question. Yeah.
Should I do that one?
Yeah, sure, go for it.
Theoretically, for a really long time, we chose JavaScript. I don't know if I've said this before, or if maybe that was something I'm going to say in the future, but we chose JavaScript to replace Java applets because it's extremely, extremely durable. The JavaScript was present in Brandon when it was acquired, and the JavaScript written in 1998 still functions exactly as intended. So it's an technology. It's pretty well embedded in the future of the web, and I don't see browsers deprecating the use of vanilla JavaScript for a really long time, if ever. And by updating from HTML3 to HTML5, that's the most recent web standard. So, you know, HTML5 will eventually become deprecated, but most likely not for at least 10 to 15 years between a different web standard. So I think there's a really good possibility that Brandon is up and visible for 20 plus years.
Okay, thank you.
I just wanted to add just briefly. So I think while I agree with Emma, I think if we look really closely, maybe at some of the visual elements, some of those things may not render as we thought they were going to render in 2017. So yeah. I would say that the kind of backbone of the code will last a very long time and is not going to break in the same way that the Java applets broke, where you don't get any functionality. But I think that it is advisable to keep monitoring the piece over time to see how small things like, you know, maybe the positioning of images by a couple of pixels, or the way the scroll bars might look, or small aesthetic differences. It's definitely worth monitoring over time to see how those might change according to different updates to browsers, because unfortunately we don't have very much control over how people who develop browsers are implementing different standards. So that's unfortunately something we don't have influence over.
Yeah, no, absolutely. Yeah, the backbone is fine, but browsers change all the time, and cross-browser compatibility is a real problem. Yeah. Why didn't we use an emulator? Sorry, my cat was being weird. So we didn't use you're cutting in and out a little bit, but we didn't use an emulator for a couple of reasons, and I'm sure Jonathan has some stuff to say about this too. But primarily, basically, the piece was so big and had so many different needs and specific requirements that running it in an emulator didn't actually result in the restoration of its full functionality. Parts of it were still unusable, and it basically just wasn't a viable solution for us. And from a conservation perspective, we decided that that was fine because there was nothing in Brandon that used like Netscape Navigator as an art form. So though it was designed to be used with that era of technology, the browser that it was being viewed in wasn't inherently part of the work. It was more important to the work that it be viewable on common technology that people had. So that was conservation justification. And again, basically, emulators were tried and it just wasn't a viable solution because of the complexity of the work.
Any other questions?
Yeah. I think we can continue to back to the slide. Yeah.
Okay. I'll just add one thing to what Emma said, which was a good summary of why we chose code migration as opposed to emulation. I think also the fact that Brandon was something that happened over, Shu Li called it a 1-year project, and it actually happened over more than a year. So it's a website that's very cobbled together. And not only was it cobbled together even during that first period of its creation, but also there were multiple interventions over time. So it's actually, kind of cobbled together between 1998 and probably like 2014. So as a result of all of these people changing things, it doesn't make sense and it doesn't even function properly if you try to trap it in a certain period like 1998 Netscape. It just doesn't function properly that way because it's this cobbled together thing. Let's see. Let me go back to sharing the screen, and we'll continue with the slides. Just hang on. So Emma's going to discuss some of the restoration challenges that we encountered while we were working on this.
Yeah, so I mentioned Java applets earlier, and we wanted to kind of highlight a particular one that was difficult to fix. So this one was called the surgery applet, and you can kind of see on the bottom there are 3 distinct images, left, center, right. And each of those images was being replaced every half second by a new image, in addition to the magnifying element that you can see. So the original Java code actually was pulling every half a second from 1 folder, 2 folders, 3 folders to create this kind of cyclical appearance of the photos, and it was handling the magnification. So to restore all of this, we actually took the original images in each of the folders and turned them into a GIF. And we did this for a couple reasons. One, GIFs were already present in Brandon. It was a web technology that was used extensively throughout Brandon. So it wasn't like we were introducing a new file format, which is something that we wanted to avoid doing whenever possible. It also allowed us to do away with this dynamic grabbing of pictures, which meant that the consistency across browsers in speed and appearance was always the same, which was a huge bonus. Different browsers have different requirements for where you can fetch files, even on a local server, and how secure you have to be to do that. So by turning them into GIFs, we basically ensured that it would look exactly the same across all of those platforms. And as with the other Java applets, we rewrote the Java in JavaScript. So Java, you don't really need to know much about it besides it's a heavy back-end language that for a while was used in the web, but it's very, very old in terms of coding. So we chose JavaScript to replace it, like I mentioned earlier, because it was already in Brandon. So again, we got to avoid adding new technologies because it's extremely durable. It's unlikely that vanilla JavaScript will ever be rendered unviewable by browsers. And it's also a really slim language. So this Java applet, for example, took like 300 lines of code in Java originally, and we were able to reduce that to about 50 lines of JavaScript, if that. So it allows for a much simpler, more readable product in the end.
Let me see if I make it full screen, if we can see it should be an animated GIF. There we go. Do you guys see that?
So, yeah, you can see the photos are changing. The person on the right, you'll see actually an actor, Shuli, had to do photos of Brandon. And the magnification was also handled through JavaScript, and it's cursive reactive. So the user is mousing over these cycling GIFs to zoom in on the photos. And so the next one that we kind of wanted to talk about was something Jonathan mentioned in the navigation. It's mix-up MooPlay. So the MooPlay chat, like I said earlier, was modeled after multi-user dungeons, these chats that were really popular at the time. And the screen that you see on the left, the one with all of the words, is generated through a Perl script. So Shuli did a really, really interesting thing here where she had a bunch of writers basically write full-length short stories. So there were fully developed characters with, arcs, everything. And the full stories are actually present in the code base of Brandon. But the screen that you see on the left, the Perl script is actually going through all of these full stories, chopping them up and choosing sentences from each of them, and then populating this file with it. And whenever it encounters a character name among the things that it's chopped up, it will highlight it, underline it, like you see with Dawn Monster. And there's a couple other keywords where it will basically highlight them and allow special behavior. So by clicking on Dawn Monster, you create this pop-up chat box that you see where it says Dawn Monster has joined the chat, which means that this chatbot, basically, this chat box is now populated with all of the dialogue associated with Dawn Monster. So once you select a character, it can respond with any of the dialogue that was written for it. So you can type something in the sendbox and you'll get something like, let me put it this way, which is a reply from either X or Dawn Monster, one of the characters that I've added. And as a user, you get to set your name, set an alias for yourself, and select from about like 32 genders. The gender is a drop-down box, and I think here I said, my name's Emma, please call me Cowboy, my gender is neuter. And yeah, it's a really, it's basically a pseudo chat, but the user is meant to feel like they're actually interacting with these real characters, even though they have limited phrases they can draw from. Oh, and the pop-up boxes that you see, pop-ups are used a lot throughout Brandon. Each of the characters has a pop-up box and a unique GIF associated with them. So there's this text element, there's this pseudo character that you can chat with, and then there's also this unique GIF based on that character. So we can see John Monster and X's GIFs in the left. I think this is...
Yeah, I think what we were trying to show here on this slide was that the MooPlay chat was a case where we couldn't actually look at the original site in order to compare it with the restoration, because in the original, it, as of 2016, 2017, when we were working on the restoration, the MooPlay chat wasn't functioning at all, and we couldn't get it to function. So unfortunately, we had to rely on the only documentation that we had, which was images actually obtained on the right, images actually obtained from the Brandon site itself.
Yeah.
And then on the left, we had some video recordings of a Skype interview with Shuli Cheang, where she was using the MooPlay chat while it was still functioning in 2012. And so we were looking at frames of that video recording to see, to make sure that it was functioning according to the information we had, which was unfortunately very limited.
Yeah, we had that and whatever we could glean from the original Perl code. So this is where the source code analysis came in handy. So this is just an example of kind of the HTML migration that we talked about. Blink tag is interesting. It was the first of the kind of slated to be deprecated tags to be deprecated, mostly because people were really annoyed by it, and browsers were sick of rendering it. So before the restoration, these elements that were supposed to be blinking were just sitting there. And you can see after the restoration, we have this GIF, we've restored functionality. And the way that we did that was actually to keep the original tags untouched and in place, and to add JavaScript. So when a browser deprecates a tag, it basically just says, I'm ignoring that. So you can see the text still shows up. The actual text of the tag and its styling that was being applied to it is still there. It's just non-functional. It's saying, I'm ignoring that you're telling me to blink. I don't care. I don't do that anymore. So we were able to basically, I'm sorry, I got confused by feedback. We were able to basically just add JavaScript to the web page that selected the tag that was already present and applied some CSS stylings to make it blink in and out again. And this was a really great thing from a conservation perspective, because we were able to keep the original code untouched, and we just had to add about 3 lines of JavaScript. So it was extremely reversible, it was very simple, and allowed us to reanimate this code that was part of the original.
So of course, after all the coding was finished, we had to actually make the restoration code live. And there were several steps involved in this complex process. And our collaboration with Guggenheim's IT department was extremely important here to make everything go smoothly. So IT set up a test environment for us that was available on a non-public web server. So we were able to take Emma's code and bring that to the test environment and test the restoration on a live web server. We were also able to give that URL to the artist, and she was able to look at the restoration and then approve what we had done before anything went public. So during this testing process, we were also using a feature of GitHub called the issue tracker, and this is a way in coding projects where developers track bugs and other issues with their code. We found it was very helpful to document discussion about a certain bug or a certain intervention that we were going to do. And we think it holds a lot of promise for conservators who are working on restorations or also working with artists. And I'm just gonna briefly show you the issue tracker here. Okay, so minimize that. Okay, so this is GitHub again. This is our repository for Brandon, and I've just opened the issues tag here, and this is one issue here. So this is just to show you, we have a discussion on the size of scrolling text for the gym episode of the road trip. Here's where I bring up the issue. So this is Emma's discussion of some of the code. And again, you can see that this is a nice threaded discussion where we can track our thoughts on it. You can also link to a specific commit, so a specific change to the code. And then another nice thing about the issues module is that you can also add screenshots to show what you're talking about. So when the restoration was done, we basically exported all of these different discussions. So we now have that as a record, as documentation of things that happened during the restoration and our justifications. So yeah, so the issue tracker we think is actually a great tool, and we've used that for other subsequent web art restorations. So in order to make the restoration live, finally, after all the testing was complete, we were happy with everything. The artist was happy with everything. We needed to point the original URL, brandon.guggenheim.org, to the new restoration code. And so IT had to do that behind the scenes. And at that point, once the URL was pointing to the restoration, that's when the work was public. We also took several steps to preserve pre-restoration versions of the piece. So of course we backed up all the original files of all the different previous versions before the restoration. We also asked the IT department to create an image, a disk image of the web server that was running Brandon before the restoration. So a disk image is basically a copy bit for bit of the hard drive of that web server. And this gives us basically a historical snapshot of the server environment, as well as the software dependencies that are required on the server to run Brandon. We also did some web archiving, as you see on the right. We used Rhizome's web reporter to create web archives of the previous pre-restoration versions of Brandon. And a web archive is basically a capture of a website that's interactive. So with these web archives, you should be able to put the web archive in a web archive player and then actually interact with older versions of the site again. And then, of course, as we mentioned, we had many screenshots and screen navigations of previous versions that should also serve as reference. In addition, the artist asked us to create a a new section. He wanted us to add a new section to the credits page to discuss why we did the restoration, who worked on the restoration, and I can show you the credits page briefly. So if we go to, so this is brandon.guggenheim.org. This is the site itself. So if you click on the word Brandon, then you're taken to the credits page. And you can see below here in this bottom part, it says Brandon 2016-2017 restoration. And then we have all the credits here, why it was restored, and a summary of what we did, and notes about how to experience Brandon, because we didn't want people to think that they could look at it on their iPhone because it doesn't work well for mobile phones. So we wanted to just give them technical notes on how to experience it best. So let's see, go back to Keynote. And finally, we just wanted to thank everyone who helped with the restoration project, and yeah, all the people we owe some debt of gratitude to. And now we can take any questions. And I'll
Okay. I saw Slido. There's 4 questions there. Okay. So the first one is curious about Shuli Zem's comment and attitude about net art conservation based on your experience having conservation with artists.
Mm-hmm.
You want to know all question, or you just one by one?
One by one, maybe.
Yeah, make it easier.
Yeah. Yeah, she was great to work with. I mean, I think from my perspective, she was really, really open to giving some background when we needed it, from a technical perspective, and really open to collaborating with us, which was really great. And she was really excited to see the work be restored.
Yeah, I would say that that was the most important thing for her, just that we were able to get it to a state where people could use it again. I think that was primary on her mind. So she did really appreciate that. And I think she actually did appreciate the care that we took, and all the detailed research and work that we took in trying to keep it as close to the original as we possibly could. Yeah, so she was involved throughout the process.
Okay. And did you also use Git to keep track of archival documentation of conservation?
No, not for this project. We didn't do that. I think that's an interesting idea, but not something that we tried in this project. We were just using Git for the code itself, and as I mentioned, the issues. So the issues, we saved copies of those as a way to, as a form of documentation of the treatment.
Okay. And I want to follow this question, like in GitHub, it's only by who working on this project, they can use track, and or the other people in GitHub, they can also reply or help you in this case.
Not in this case. So GitHub has public and private repos. So if we had made the Brandon repo public, then anyone on GitHub would be able to open up an issue, to comment on issues that existed, And that type of openness is mostly used for open source projects. It's really helpful when you need a lot of community feedback. This, obviously, a lot of the code is kind of proprietary. It is the artwork. So it wasn't open to anyone. It was the only people who had access were, I think, myself, Jonathan, Dina, a couple people involved in the restoration were viewing it, but the only actual committers of code were myself and Jonathan. And that was just to keep a really clear record of what interventions had been taken, why we wanted to keep it really simple. The interesting thing about Brandon, though, is because all of these interventions are noted in the code, anybody from the public can just inspect Element in the browser while viewing the piece and see some of these documentations if they were really curious. So the actual product, in a way, is a lot more public than the GitHub was.
Okay. And so it's not possible, like people can download the code and make changes to it, right?
I'm sorry, can you repeat that?
Okay, so I said it's not possible. People can download the code and make changes to it. It's right.
No, I mean, theoretically you could, like, you can save any web page that you're looking at, but there's parts of it that aren't visible to the viewer. So nobody just visiting the site would be able to download all of Brandon. It just wouldn't be possible.
Yeah. And which part does Guggenheim own, and which part is the artwork, and also the final code or the final code or the whole history of change is belong to which? Yeah.
I mean, when the Guggenheim acquired, source code is interesting, right? But my understanding is that when the Guggenheim acquired the piece, it acquired the source code. So the Guggenheim owns the particular version of code that it acquired in 1999 or 2000. I'm not sure exactly when it was acquired. That's my understanding of it.
Yeah, that's accurate.
Yeah.
So it was a commission by the Guggenheim. So the Guggenheim paid Cheang to create this artwork, and when it was commissioned, we looked at some of the archival documentation and found that when it was commissioned, it had always been, like, the intention of the curators had always been to bring it into the collection. Unfortunately, in 1998, 1999, no one was quite sure how to bring a web artwork into the collection. So there was a bit of a lag between when the site was actually created and when we started getting copies of the source code. But yeah, as far as ownership, since it was a commission and acquired into our collection, the Guggenheim does own the source code.
And right now, the current version of the work is the version being served from the Guggenheim server, which is also captured in the Guggenheim's GitHub, which they have control over.
Okay, and next question is, how did you deal with sites no longer online?
There was only one site that was entirely no longer online. And for that, we basically just commented out the part that would actually try to take the user to that site, but we left the reference because the reference was important. It was a piece of the artwork that this used to go somewhere, but we basically just deactivated the link so that it would no longer try to take you to a website that wasn't there. That was our compromise with things like that. Just to make sure that like the notation of it, like its presence, was part of the piece, and it's not really the fault of the artwork that that site no longer exists.
But I do think that since Brandon doesn't have a ton of external links, but there are some. So again, like some system of monitoring is advisable in this case, and ideally automated monitoring. So we have a script or something that is checking the links every so often, and if one of the links doesn't go anywhere, then we get, like, let's say, like an automated message saying that a certain link is down.
Yeah.
And then we can figure out where to go from there. But we worked with the artist on the links that were dead. We were able to work really collaboratively with the artist to figure out different creative solutions for some of them. I know one of them, the Center for Civic Dialogue, the artist actually suggested that we replace that with a link to the archive for that organization within Fales Library at NYU. Yeah. So instead of linking to the organization itself, which no longer exists, we were instead linking to its archive, and I thought that was a good solution.
Okay, we have last question. Is about what would you suggest to include in deliverable for a newly acquired web art in order to make future restoration easier?
Oh God, like, okay. Ideal scenario, when you're acquiring a new web art, you have a disk image of the computer that it was created on. You have multiple copies of the source code in full, and you immediately put those things into a Git repo. If it was developed on, if the artist was using some sort of version control software to develop it, you should also have that history, which is pretty easy to port over. So ideally, you have a clear notes on when it was acquired, the system it was originally developed on, all of the technologies used within that piece, any version control history that exists within that piece, and you immediately store it in version control and in multiple locations with fixity checks just to keep an eye on data rot. Did I miss anything? I think that's the...
Those are really good suggestions. I would add a couple of other things. Like one, I would want to do an interview survey with the artist to figure out what the software dependencies are for that web artwork. So even if you have the code, you may not realize certain software dependencies to run that code. So basically, I mean, the most direct way would be just asking the artist to provide a list of software dependencies. Also, I would recommend that they basically write a summary of what the work actually does. If it's kind of, if it's pulling from another website or another web service, they should be listing that so we know that that's a potential vulnerability. If it's pulling from Twitter, let's say, we should know that. And what type of query it does and things like that. And then finally, I would also ask that they provide instructions on how to start it up. Like basically instructions so that if you just have a very vanilla web server, how do you get this thing running? And that will help us in the future, if we ever have to port this, maybe currently the piece is running great on this one web server and they want us to have that, but what if we have to move it to another web server? What are the instructions that we need to know in order to get it running properly on a new clean web server?
Yeah, I would also, I had one more, which is just really, really specific notations about any technologies used. So if it's like a simple web app that's using Flask, you want to know exactly what version of Python is being used. If there are any external packages, you want to note what version of those are being used, because those dependencies can be really difficult to track down later. So as long as you have it at the beginning, it's going to make any intervention or any investigation a lot simpler.
And then finally, just to add one last thing, well, the artist doesn't necessarily have to provide this, but the conservation department could do this, or the artist could do this, which is some kind of video documentation of the piece working, so that there is a reference of, okay,
yeah,
this is what it looked like when it was created. And, someone basically going through, and if there are links, clicking the links, interacting with it, clicking the buttons. So just so that there is some sort of reference for the future.
Yeah.
Yeah, I think that would be a great way to go. And I think today's lecture is almost finished. So before we finish, have you guys want to share or say something in the ending?
I just wanted to thank the Taiwan Digital Art Foundation for having us, and I hope you enjoyed the lecture and were able to learn from it. And thanks to everyone who helped set this up.
Yeah, thanks so much for having us speak. Brandon's a really, really cool piece. I'm really excited to talk about it. I hope everybody checks it out. Thanks again for having us.
Okay, and thank you also having to share like this so many details of this case, and hope we can keep going to look forward. So thank you guys for today. Goodbye.
Bye, everybody.